All right, good morning, everybody. We'll just wait another minute to see if we have some last-minute stragglers joining into the class. We're still missing quite a few people, so we'll just wait another quick minute, then we'll get started. All right, we'll get started. Hopefully those last-minute people will be logging in soon. Otherwise, the video is always there. So good morning. Friday, finally, 1 week to go. The plan for today is as per usual. We will go over any questions that you have that you want to go over. We'll finish up the notes from yesterday, and then we'll get into the notes afterwards. So I see some questions popping up. So I'll go over as much of those as I can. Not everything, because we do have to get into the new material, but as many of these as I can, I will try to go over. Okay. While the questions are popping up, I'll just make sure you can see my screen. The questions about assignment 9. So just to acknowledge that there were this assignment, it was assignment 9. Okay, I'm going to do one of these things at a time. Assignment 9, I'm going to leave those questions just because a lot of those questions we didn't get almost any practice on yesterday because we did it right at the end. So we're going to do a whole bunch of those examples now. And then we can take a look at assignment 9 either at the end of class or on Monday morning, because after today, you should have the tools to be able to do that better. The question about could we also get the checklist today for the memory aids? Like I said yesterday, you'll be getting this checklist today at some point. I'm not putting a timestamp on it, but it will be uploaded at some point today. Like I said, you can start building your memory aid based on the mock memory aid and the fact that you need all the CST topics and you know what we've covered so far in this class and you have the notes to build that up. So you can start building your memory aid in the meantime. But yes, I will be posting a list. That list is going to include all the CST topics and anything that we've covered together that is fair game. So again, a reminder, all that stuff in CST, the analytic geometry, the different functions, triangles, metric relations, like all these kind of things are completely fair game for the CIPROB and completely fair game for the final exam. So make sure you're looking at those as well. Okay, so I'll try to do as many of these as I can. So we'll take a quick look at the first one that was asked was assignment 6, number 3. We did do this together. I'll go over it quickly again, but we can't spend too much time on it because we did spend a whole bunch of time on it last time. So this is the one where Mary is building a property. So basically with this one, what you are doing, so this part's the more difficult part. So you're creating this line. So we have the line here that is given by the inequality 7x minus 20y. Is greater than or equal to 0. So you had all these points. And essentially you had to figure out, so her property was this trapezoid. And you had to figure out, we need to know where the marshlands overlap with her property. So honestly, because her property gets cut, it's either going to be in this part or in this part. So first, we're just going to figure out which part that is. So I'll test a point here. Let's say 100 and 0, really doesn't matter. So I have 7 times 100 minus 0 is greater than 0 question. So 700 is greater than 0, greater than or equal to 0. That means I'm shading this way. But we have to remember that we're only looking at what overlaps with her property. So we're basically looking in this triangle area right here. So that's the marshlands on her property. So you need two things. We need the area of this triangle. So area, I need this base, and I need this intersection point, because here that'll give me the height, whatever this x value is, and then this y value here will give me the base. So this is 300. So I plug in x is 300 into the rule. So 7 times 300 gives me 2,100. The 20y moves over and becomes positive. So I divide by 20 and I get 105. So this point is at 300 and 105. What that means is the height of the triangle is the base of the triangle, sorry, is 105. Then you need to find, your next step would be the rule of DC. Once you have the rule of DC, you're going to use systems to find, we'll call it point E or point E, where our line intersects CD. And from there, whatever this x value is, you do 300 minus the x value from this step to give you the height of the triangle. And then 5, you're going to calculate the area of the triangle. Okay. So that brings me to, yeah, when you're doing the rule of DC, you get the slope and then you already have the intercept. So you do slope, then intercept. The next questions I see. Assignment 8, question 2 and question 3. Good question. Assignment 8, question 3. A bookstore offers its customers a loyalty card. With each purchase, the bookstore stamps the cards with 1 or more stars. The value of the purchase before taxes determines the number of stars stamped on the card. When the card is full, the customer receives a gift certificate. Function F described below is used to determine the number of stars stamped on the card according to the value of the purchase before taxes. And you're given this rule. Y equals negative 0.04x, and it's a step function. So Francesca says, if I buy 2 novels at different prices, my card will be stamped with the same number of stars. So if you have 2 novels, different prices, that's the thing. And then if you buy them together, she's saying that that will be the same as buying them separately in terms of number of stars. And then the question is Francesca's statement true or false? So the idea with these problems, when you have a problem that says, is this true or is this false? I'll make a statement here. The vast majority of the time, like talking 90%, 95%, 98% of the time, it's false. It's false because it is extremely hard to prove this. If you're proving something is true, you need to prove that it's true for every single case in the world, which means you need to prove that it's true algebraically. But if you're proving something is false, you need one counterexample and the whole thing falls apart. So your job with these type of questions is to start to try to find a counterexample. So you're literally choosing different things that fall within these criteria to see if I can find a counterexample. And if it doesn't work, I try another one. So you pick book prices. Trial 1. Pick book prices. Any book prices. $12 and $59. Who cares? So now you're testing how many stars you're going to get if you buy them together or if you buy them separately. So if I'm buying them together, 12 plus 59 gives me 71. So here I'm plugging in x is 71, and here I'm plugging in x is 12 and x is 59 differently. So I get y is negative. So y is negative 71. So negative 0.4 times 71 gives me negative 2.84. This drops to negative 3, so that gives me 3 stars. So if I buy them together, I'm getting 3 stars. What if I buy them separately? Y equals negative 0.4x. So 0.04 times 12 gives me negative 0.48. This drops to -1. That gives me 1. Same thing here. Here, this gives me -2.36. This drops to -3, which gives me 3. Separately, I get 1 plus 3 is 4 stars. So if I buy them together, I'm only getting 3, but if I buy them separately, I'm getting 4. So her statement's false because I have an example that says, oops, sorry, your statement doesn't work for this example, so you can't make a statement like that. So maybe on the first time you got the same amount of stars. Pick other numbers and then you try it again, because there are a ton of combinations that'll give you a different answer here. You just have to find one. So once I found one, I'm done. I just say, based on the counterexample above, her statement's false. Like, that's all you have to do. Because like I said, once you have one counterexample, you're done. You pick random numbers, whatever you want. Like I picked those out of my head. Yeah, we're doing 3 now. Yep. That was already a question that was asked. This one, so that was a final exam level. This one is as well. So they're meant to be hard. A grocery store provides a home delivery service. To determine the delivery cost, the grocery store uses function f described below. So we have y equals a -1/4 to the x, but we don't know what a is yet. David, Jonathan, and Mary buy their groceries at this store. They each had their groceries delivered to their house. David lives 16.2 kilometers away and he pays $12.50. So before I even move, I'm going to use this point to find what my A value is. So $12.50 is going to give me A, -1/4, 16.2. So -1/4 times 16.2 gives me -4.05. This drops to -5. And if I divide by -5, I get that my A is -2.5. So my rule is -2.5, -1/4 x. So I can't make a move until I do anything. It's 16.2, not 16. You don't take the greatest integer until you have one number in here. So -1/4 times 16.2 gives you -4.05. If you remember on the number line, you have -4, -5, -4.05 lands here. You're dropping to -5. So I'm using this point to solve. So I plug in the x and the y. Again, you don't do anything until you have one number here. So -1/4 times 16.2 gives me -4.05. And from this -4.05, it's a negative number. It drops back, if we remember. So it goes to -5 when I take it out of the greatest integer bracket. And then I just divide both sides by -5, and -2.5 is my A. it says that it costs $5 for Jonathan. So Jonathan is $5 and Mary is $10. Yeah, exactly. So you just created your rule and now this is the rule that we're going to be using for everything. So Jonathan being $5 means 5 gets plugged in as a y. So I solve, I divide by negative 2.5. That gives me negative 2. So we remember that we just dropped these brackets. Negative 8 is negative x. So we can make these positive. 8 is x. If I go to my rule, b is negative, so my step is open to closed. This is my solid dot. And the length is 1 over 1/4. That gives me 4. So you just flip it. So this is 4. So from there, this gives me 8. And I drop back to 4. Okay. The greatest integer brackets work as brackets. Now, before you do anything with the brackets, you have to do the math that's on the inside. So you have to put this together and then you take the greatest integer of it. So if there's anything to be done on the inside, it gets done first. So when I plug something in here, I don't just say, well, I don't take the greatest integer of each thing individually, because this is not something that applies to each different term. You do the whole math thing, and then you take the greatest integer of your solution on the inside. So you only take the greatest integer of something once you have one term on the inside, one number and one number only. Is this clear? For the 1/4, you don't take the greatest integer of it because it's 1/4 x. There's nothing you can do. And here, you don't take the greatest integer of 1/4 because it's put together here. So we put it together first. So you can't do anything like that, okay? Here, 10, same thing. I divide by negative 2.5. That gives me negative 4. So negative 4, I drop the brackets. I multiply, it gives me negative 16. And these cancel out. Again, it's the same analysis as I just did here. So 16 is going to be my end, and I'm dropping by 4 to give me 12. This is where it gets a little tricky. You are told that they are 6.2 kilometers apart. So if I know that they're 6.2 kilometers apart, if he lives at 4.1, so if he's 4.1 from the grocery store, if I add 6.2, that's what's on the screen. So if I add 6.2, I get 10.3. That doesn't fall within the range. So he can't live at 4.1. So his distance is somewhere between 4 and 8 from the store. And her distance is somewhere between 12 and 16. But they're 6.2 kilometers apart. So if she lives at 12, he would live at 5.8. Because 5.8 and 12 are 6.2 kilometers apart. Does that make sense? So if he lives at 5, if he lives at 5, if he lives at 5, let's say, 5 plus 6.2 is 11.2. That doesn't fall within her range. We know that she lives somewhere between 12 and 16, so he can't live at 5. So the closest, so if she's at 12, which is the lowest that we can go for her, that means he's at 5.8. So anything below 5.8 is not going to work. So we have to cut down his interval. So he can't be at 4. He can't be at 4.1, 4.2, 4.3, 4.4. The first one he can be at is 5.8. And then he can go all the way to 8. We know she falls within this interval. We know he falls within this interval. We also know that they are 6.2 kilometers apart. So think about it. If he's at 4.1, you add 6.2 to find out where he would be. The 4, 8, and the 6, 12, 16 comes from us solving here. Well, they gave us a y, $5 and $10. What do we do when we have a y? We find the x. So we did. And then here we know that, so we know 3 different things. We know that he's within this interval because if he's not within this interval, he's paying more for groceries or less. But we know he paid $5. And she's within this interval because she pays $10. And if she's more than 16, she's at a different interval. Or if she's 12 or less, she's in a different interval and she won't pay $10. But we have this added bonus of them being 6.2 kilometers apart. So we have to figure out how to reduce one of their intervals. And we want Jonathan's because that's what the question is asking for. No, they're 6.2 away from each other. So he is between 4 and 8 kilometers from the grocery store. She is between 12 and 6 kilometers from the grocery store. They are 6.2 kilometers apart. What this means is we have to figure out what the possibilities are that he could be from the grocery store. So I'm going to take the closest she could be, the lowest part of her interval, to find out if this is the minimum for her. So let's figure out the minimum for him. So to figure out the minimum for her, we take the 12 minus 6.2. That equals 5.8. That gives us the minimum for Jonathan. If we take the maximum, 16 minus 6.2, that gives me 9.8, which is also the maximum for Jonathan. So then we compare. If 4 is actually a minimum or 5.8 is the minimum, we go with 5.8. If I'm saying that 8 is the maximum or 9.8 is the maximum, what's the true maximum? 8 is the absolute max. We can't go over 8. So 9.8 doesn't apply. So this is where he lives. Taking into account how much she pays, how much he pays, and the distance apart they are. All right. Let's continue. So again, I did see that there were questions about assignment 9, but I want to wait until we go over again and finish what we were doing today on assignment 9. Okay, so I want to finish up what we were doing yesterday, and that will help you for assignment 9. So if you were still confused about assignment 9 after today, that's when you really shouldn't be. So I'll just let us finish this and then give you another chance to look at it, and then we can go from there. The question right now is the exam an actual provincial exam? The answer is yes. So provincial exams are offered 3 times a year. In June during the school year, in July/August, wherever it tumbles, and in January. So this is an actual provincial exam, just like it was in June when you did your CST. This is a provincial exam, but it's for the TS. So it's the same idea, same layout, same expectations, all of that kind of stuff. Okay? But do they know the bridge course and the... What do you mean and the paste? But what do you mean the paste? Okay, look. The TS exam is offered 3 times a year. That's it, that's all. It's not going to be easier in the summer or harder in the winter or harder in the summer. Like it's the same level of exam for all 3 exam periods. So you've got the June, the July, and the January. It doesn't matter when you take it, the exam difficulty is the same. You know, though, with your experience with CST, sometimes you luck into a slightly easier exam, sometimes they're harder. Depends, but there's not a pattern to that. It's just like you have the exam, the expectation is that the difficulty is the same. I know you're getting a little worried, but I'd like you to stop getting so worried, because remember that we're going to take a look at a couple of mock exams, and you're going to see that there's a lot of stuff that you did in CST. Those type of questions come up as just pure CST material. For instance, you know, the question on linear regression where you have to estimate the correlation coefficient, you could get that as a Part B question. And that has like nothing to do with the new material that we're going to cover, right? So there are a lot of questions, foundations, where you could have done these questions before you started taking the bridge course. So the bridge course is just for the extra material. So even if you're having difficulty with certain things, you still can pass. So I don't want you going in saying like, oh, I'm not going to pass because I'm having trouble with step functions. Like, don't forget that you have so much material to fall back on too. So you need to be paying attention to your CST material and to the new material. Why do you have to get a 75%? Okay. That depends on your school, what your school's requirements are to get into TS next year. So some schools require a certain amount and some schools don't. So some schools say if you pass, you go in. If you like, there are different requirements depending on what school you're at. Okay. So I can't answer that question for you. I have no idea, guys. I don't know the requirements for every single school. Okay. The person that would know that would be your guidance counselor. So you could feel free to send them an email to know. In terms of preparation for this, the assignments, all of the assignments I'm giving you, those are exam level questions for the new material. So if you're doing them, which a lot of you are not, you're getting exposure to exam type questions. So think about that when you're doing or not doing your assignments, because less than half of you are doing them. They're hard. Yes, they're exam level difficulty questions. And you do know them. Like I haven't gone, like I'm not giving feedback on assignment 9. You should be going back and doing assignment 6 and 7 and 8. Like every time I go to give feedback on an assignment, less than half of you have completed it. And I don't give assignments until I don't give feedback until at least 2 days after I signed it. Like for assignment 10 for today, I'm not going to give feedback until Tuesday to give you a chance to finish it, even if we don't finish the material today. And I give you feedback. If you submit it late, I will still go back and give you feedback, but only a few of you are choosing to do this. So at the end of the day, there is no excuse because I'm giving you feedback regardless of when you complete it. So I apologize to the people who are completing their assignments on a regular basis. And there are a few of you that it's coming up every time and you're completing the assignments, and that's fantastic, but there are a lot of you that aren't. And I hear you that you're very worried about this exam, but the only way to get prepared is to do as many of those assignments as possible on your own with checking your answers. Please try not to mute me. You need to do as many of the assignments as possible. Well, if you forget to submit them, that's okay. No problem. I figured it's an accident. If you forget to submit them, I can't help you. You just have to remember. But like I said, what you need to be doing to prepare for this exam is doing all the assignments. Even like go back this weekend and do assignment 1, 2, 3 if you didn't do it. And you'll get feedback. It's just you need to practice these questions. You have all of the solutions to all the handouts, to the assignments, so you can look at them, but you have to be practicing the questions. It's not enough to leave class and say, I understand. So if you're worried about the exam, the best thing you can do is print out all of the handouts, do all of the assignments, and do all of those questions, and then you should be fine. Ask for clarification on what you're not understanding. Send me emails. I'm really quick on answering emails. I'm within 24 hours for sure, usually a lot shorter than that. But you have to be getting prepared and taking this seriously, or it won't be easy. it's hard. It's 3 weeks. It's tough. It's condensed. That's kind of the point, the nature of the beast. So you just have to power through as much as possible. You have a week and a half left. Next week is going to be a little bit lighter in terms of new material if we get through the stuff today. And then we'll have some time, like Friday, I want to do review or do some practice problems, part of Thursday as well. It's going to be lighter next week as of now, but you have to do stuff. You have to be working. That's all I can say. I understand it's overwhelming. I know it's a lot of work, but you just got to do it. Otherwise, it's not going to go as well. Okay? Please, please, please do as much work as possible, and please send me emails if you're not understanding something. Like I said, I'm very quick at answering those emails. All right, let's continue. All right, so yesterday we started to talk about exponential function. All the different things you could do with it. And then we got to solving problems. And solving problems with the tool that you used last year or during the year, which was guess and check. And we were like, okay, well, there's got to be a better way to do this. We need to be able to invert an exponential function. So we looked at what this looks like, the inverse of an exponential function. So if we remember, it's a flip. Okay, so we flipped it over this line, we reflected it. So some general notes about it. It is the inverse of an exponent. So we call this a logarithmic function. It is the inverse of an exponent. It in itself is an exponent. It will allow us to solve equations where the exponent is a variable without having to guess and check. It has an asymptote at y equals 0 this time, so at the vertical axis, meaning it's never going to touch y equals 0. Just like the exponential function will never touch x is 0, this one never touches y is 0. Now, this brings me to class 9, the quiz. Question number 3. So question number 3 says, function f described below represents the number of inhabitants in a town according to the number of years. So you have this exponential function. Which graph below represents the inverse of the function? So if you happen to get a question like this, how you handle this is you are looking for, first of all, the graph that has the shape of the inverse. So in this case, the one that has the shape of an inverse so here, you go to the shape of the inverse here. So this one does not have the shape of the inverse, and this one does not have the shape of the inverse. So I've eliminated A, and I've eliminated C. Okay. I've eliminated A, and I've eliminated C. Okay, because neither one of these has the shape of the inverse. Now we need to understand that exponential functions and logarithmic functions cannot pass through 0, 0. This passes through 0, 0. So this one gets eliminated. That leaves us with this picture. So this is the type, this is really the only type of question that you could get with the logarithmic function. Other than that, you're going to be using the logarithmic function to get just to be able to solve more exponential problems. Okay, number 1 on this as well is what you're confused about? This is an exponential function. Is anyone going to argue with me that it's an exponential function? There are this typical type of questions. You've got percent increase. You've got the bugs and the insects and the bacteria. And you've got like car depreciation. But as soon as you see the percent increase, then you have an exponential function. So automatically A and B are eliminated. Then you just calculate the points, and you're given the point 3 and 6, 6, 5, 5. So when you create the rule, you plug in x is 3 to see what y you get, and x is 2 to see which y you get, and that will give you D. The exponential and logarithmic never go through 0, 0 because an exponent can never make something equal to 0 exactly. Okay, so exponential and logarithmic functions can never pass through 0, 0. So like I said, that's pretty much the only type of question that you could get with the logarithmic function itself. We'll go over one question of matching basis because we are extremely behind today. Look, at the end, matching basis is not something that comes up as often in the final, but the other things are. Okay, so we do need to get to that. We just really don't have time to spend because this, again, should be review from your CST when we need to get to the new material, okay? So 27 can be written as a base of 3. So 27, 1 over 27 can be written as 3 to the negative 3. And 81 can be written as 3 to the 4. So basically, you're just finding a number that they could both be written as and replace it. So this is a couple of pages prior. It says on the top matching basis. So when you have these, it's a power of a power, which means I multiply. So I get 3 to the 6x equals 3 to the 4, 10 minus x. And once I have the same base, I just get rid of the bases and I keep the exponent. So 6x equals 4, 10 minus x. So I just solved this equation now. 6x equals 40 minus 4x. If I move this over, 10x equals 40. So x is 4. All right. Then we started using this relationship and saying, okay, well, log is an inverse of an exponent. And using this relationship will allow us to solve problems when the exponent is a variable. So we started doing these problems. We're going to do quite a few more between this page and all the other pages. Okay? So what you are doing is you are isolating the term with the exponent. And then once you have the isolated term with the exponent, you flip it around using this relationship. So I have x here, this is d. So I have x here as my exponent. I have a as the solo number, so that becomes log of 19683. And I have c as my base. Base goes on the bottom. So I type in log 19683 divided by log of 1/3. So this is a 1/3 sign. And that gives me -9. And I'm done. So rather than having to guess and check, you just get -9. So you're just flipping it around. This relationship is super important. And it's written differently on the mock memory aid than I write it, and this way is simpler. So make sure you write it this way for your memory aid, okay? We'll do the next two. Actually, we're gonna jump. No, we'll do these two. Okay. So remember that when you have an exponent, it creates a brick wall that we cannot multiply into this bracket, okay? So we have to isolate the exponent term. So I'm going to divide by -2. That gives me 2/3 to the 3x equals, if you divide this by 2, you get positive because the negatives cancel out, 8/27. And now we start our flip around. So I have my exponent that gets dropped. The term on its own goes on the top. And the base goes on the bottom. So I type in log of 8/27 divided by log of 2/3. And that gives me 3. So x is 1. Because I want to divide by 2. If I divide the numerator and the denominator, I'm not actually dividing the fraction, I'm just reducing it. So I actually wanted to divide by 2. So you just type this into your calculator, like you say negative, bracket it, -16/27, and then you divide by 2, the -2, and that'll give you the fraction, 8/27. Let's do F. So again, I need to have this term isolated. So I'm going to start by moving the 120 over. And here I'll divide by 8. So 120 divided by 8 gives me 15. I now have this, so I can switch it around. This drops on its own. The 15 goes on the top, and the base goes on the bottom. So then you get 2x plus 1 equals log of 15 divided by log of 4. That gives me 1.953. If I subtract 1, I get 2x equals 0.953. And then I can divide by 2. That gives me 0.477. Can I do G, please? Yes, I can. One last one. So in this case, the term with the exponent is, just to go back to this question, how do I get 2x? 2x is here. It's from here, and it was here, and it was here. And when I moved this, I subtracted 1. So I subtracted 1. Divided by 2 to give me my answer. So here I've got this already isolated, so I just make the switch right away. So the 3x drops on its own. I get log of the solo number divided by log of the base. So I type that into my calculator. And I get negative 2.57. And I can divide by 3. That gives me x as negative 0.858. Okay, so why are we learning this? We are learning this so that we can solve exponential equations quicker and more efficiently. And we can get more precise answers. So we're going to take a look at 1 or 2 exponential word problems review. So these are the type of problems you handled in CST. And then we'll take a look at the new material in terms of what has changed. So what has not changed is the following. For exponential word problems, you have this stereotypical type of problems that you always get. You get bugs and insects and bacteria, all that gross stuff. You have percentages, you have populations increasing. You have cars depreciating in value, and you have money investments. Those are the type of problems you see all the time. So here, what we do is we define our variables. We figure out the starting value for the y. We figure out the base, so it's what I'm multiplying by over and over. If it's half-life, it's cutting by half. If it's cut into 2/3, it's cut into 2/3. If there's a percent increase, then my base is 1 plus percent over 100. If it's a percent decrease, my base is 1 minus percent over 100. And then we create our rule and answer our problem. Let's take a look at number 2. A car bought at $30,000 loses 20% of its value every year. What is the value of the car in 5 years? And how many years will the car's value be less than 1,000? So the first thing I do is I define my variables, and the new stuff that we're going to be doing with exponential is going to be highly related to how you define your variables. So it's super important to do this first. So here we have years, and here we have value of car in dollars. So I have y equals AC to the x. So the A is, what is the value that the car starts at? It's $30,000. And it loses 20%. So the base is 1 minus 20 over 100, which gives me a rule of 0.8 to the x. There are 2 problems in here that they're asking. What is the value of the car in 5 years? So we'll call that A. So y is 30,000. So you just plug in the x is 5, and you get 0.8 to the power of 5. That gives you 0.32768. And you multiply by 30,000, and it gives you $9,830.4. B says, in how many years will the car's value be less than 1,000? So for B, I'm going to plug in y equals 1,000. So I get 1,000 equals 30,000, 0.8 to the x. So if I divide by 30,000, I get 1 over 30. Try to keep it as a fraction. And now all of a sudden I can use the tool that I had before, the log tool, to solve this without having to guess and check. So I get x equals, this drops, this goes in the top, this goes in the bottom, and I get log of 1 over 30 divided by log of 0.8. That gives me 15.24 years. So that is why we use this tool. That is why we learn how to do the log. That right there, because all of a sudden the guess and check is taken away and we can find an exact answer that makes our lives a lot easier. What do you mean, how do you round? Just 2 decimals is fine, like a normal thing. 15.24 years. You use log when you're solving for the exponent. So it's when you're solving for x. Okay, so if I'm looking at this, if you look at assignment 9, number 3, this would be more of a part C type question. You could get what we just did in a part B, but you would only have to do one or the other. So it would give you the situation and then it would say, like, you'd either have to do it forwards or you'd have to do it backwards for the part B. You wouldn't have to do it for both. Okay, that's just the rule. So that's just the relationship. The relationship says when you have something, if you prefer to change it, that way it's less confusing, that's fine. But the relationship is I have something isolated equal to something, something. Okay, this has nothing to do with this parameter. Nothing. Okay, so it's just the relationship. So don't get confused on that because that'll give you a funky answer. But like I said, this would be more, this is in assignment 9. So here, this, like I said, is the type of part C question. So in this one, I'll let you try it and we can go over it on Monday. But you have to work forwards with a rule and then create another rule and work backwards. So that's what they like to do, using a whole bunch of different steps. We could set up the rule for this one. So why did that happen? So here, X would be years, Y would be money. So here, I'm starting at 2,500. My C is going to be 1 plus 5 over 100. So it's 1 plus % over 100. So that's 1.05. So my rule is 2,500, 1.05 to the X. In how many years will my money double? So double means the Y is going to be 5,000. So we plug in 5,000. I divide by 2,500 to give me 2. Now we're at the point again where we are solving for this, meaning I use the log relationship. So that drops on its own. This one goes on the top. This one goes on the bottom. And you get 14.21 years. See, all of a sudden, when we're working backwards, we don't have to guess and check, and it makes it just more straightforward. It's just like one calculation that we plug in, we do, and we're done. How's this? Not so bad? We're seeing a bit more of the purpose of the log relationship now that we've done some problems. Trust me, we're about to use it a lot more. Yeah, you could say between 14. You don't even have to write it as an interval. You could say between 14 and 15 years. Okay, so that brings us, so that was essentially last year's exponential function being solved in a different way, just like giving you an extra tool to help you solve these type of problems. Now is when we just have two separate additions to the exponential function. So now we are on notes 10. No. Just close this. Okay. So in all the problems that you handled last year and in all the problems that we've done so far, it always says it's depreciating in value every year or increasing every minute or doubling every hour. So it's 1 year, it's 1 week, it's 1 minute, it's 1 hour. If it's not 1 hour, if it's 3 hours, if it's 4 years, if it's 20 minutes, things change. So the actual like true to form rule does it this way, but I'm going to do it this way because this way takes out some of the funny thinking that you have to do to make this rule. So this is the one we're going to be using. So you should put that on your memory aid. The mock memory aid will use this one. So just be wary of that, okay? I'm going to be practicing it with this because it makes it a little bit easier. So what parameter B does is it stretches. So parameter B does a similar thing. If we go back to 1, 2, and 1. Parameter B does pretty much the same thing as C. So if you notice here, it changes it, but it doesn't change the y-intercept. And when B is negative, it flips it over here. So you don't actually notice any difference if you're playing with the parameter C or if you're playing with the parameter B. It does the same thing. So what does it represent? So we're going to, like I said, the true to form one is using the B, but I don't want to use the B. I'm going to use this as D. So B and D have an inverse relationship. So if we're using the D, that saves us from having to do flips in our brain. So the steps for the word problems are the same, except you have an additional parameter to take out of the word problem. But it's super, super important, and we're going to take a look at a couple of problems where you have to define your variables first, okay? So if I want to just define parameter D, the population of bacteria triples every 3 hours. So my X would be in hours. So D represents period of time the change is occurring. So if it's B is if x is in hours, then d is 3 because it's every 3 hours. So it would plug in as ac to the x over 3 because the rule is y equals ac to the x over d. This one can be done in 2 ways. So if I call my x minutes, my d would be, it's every how many minutes? It's every 30 minutes. But because 30 minutes is half an hour, I could have also said x is in hours. So it's every how many hours? It's every half an hour. But then when you're doing this problem, you'd plug in x's as minutes and you'd be solving for x's as minutes. And if you were working with this one, you'd be plugging in hours and solving for x's hours. Same thing here. I have the 2 different case scenarios. A car loses 5% of its value 4 times a year. So if I put x in years, 4 times a year is every quarter of a year. Say how many years? Well, it's a quarter. No, you don't have to put d over 1. Nope, 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 just plug it right in. If I define this as months, well, this would be whatever a is. You could also write this as 0.25. So it would be a 0.95 to the x over 0.25 because it's x over d. If I say this is months, 4 times a year means every 3 months. So we would get d is 3. So let's see. Basically now we're going to be doing word problems like you did, but it's just going to say something different in terms of the unit of time. So that's all that changes. Larry bought a car for $25,000. It depreciates in value 8% every 6 months. Find its value after 4 years. So we're going to do it 2 different ways. One where x is years and one where x is months, just to show you that it doesn't actually make a difference. So if you get this problem on a final, I don't really care what you do. So we know that A is 25,000. My C is it loses 8%, so it's 1 minus 8 over 100. That gives me 0.92. And now the D, it says every 6 months. Since this is in months, it's 6. So Y is 25,000. 0.92 to the x divided by 6. And now you have a rule and nothing changes. They want to know its value after 4 years. So 4 years, because I define my x to be months, I have to plug in months. 4 years is 48 months. So I plug in 48. So you get 0.92 to the 8. And if you do this multiplication, you get 12,830.47. if you decided to do this in years, like I said, I'm going to compare them so that you can see. Your A doesn't change. Your C doesn't change. It's the D that changes. 6 months means how many years? It's every half year, which you could write as half or 0.5. So this gets plugged in differently. So now I'm still solving for the same thing. You plug in, but now you're plugging in 4 years. 4 divided by 0.5. That gives you 25,000, 0.92 to the 8. And you get the same answer. So at the end of the day, it really doesn't matter which one you choose to use, as long as you consistently plug in months if you choose months or years if you choose years. So nothing changes. Okay, let's take a look at another one. A $5,000 investment increases by 2% 4 times a year. Find out how long it will take for the investment to reach $7,000. So we start off by defining our variables. X is, what do you want? Years. Y is value of investment. So I have my A value, which is 5,000. My C increases by 2. 1 plus 2 over 100 is 1.02. And my D, if it's 4 times a year, that means it's happening every quarter year. So we'll put D in as 0.25. So we have Y equals AC to the X over D. And I plug it in. X divided by 0.25. How long will it take for the investment to reach $7,000? So I get 7,000 equals 5,000, 1.02 to the X over 0.25. We solve it the same way, 5,000. So we get 7,000 divided by 5,000, which gives me 1.4. And here is where your log relationship comes in. So this drops. And you get log of 1.4 divided by log of 1.02. If you type this into your calculator, you get 16.99, and you have X over 0.25. And then I just multiply this up, so times 0.25, and I get 4.25 years. The question is it a better idea to use months instead of years? It makes absolutely no difference in the end. So unless the problem says, like in this problem for your assignment, it says X is years, so you got to use years. But if it doesn't say anything, then you use years or months, whatever you want, whatever you feel more comfortable with. Because at the end, like we saw in the problem before, at the end of the day, you get the same thing. So it really doesn't matter. I'm going to give you 2 minutes. I want you to just create the equation for these two. And then we will create the equations together. Okay, we ready or do we need another 30 seconds, minute? I'm going to take that as we're ready. So let's do this. So here, X is, we're going to use years. Y will be number of deer. So my A is 1,500. My C is 15%. So 1 plus 15 over 100 is 1.15. And it says every 2 years, meaning D is 2. So I have Y is 1,500, 1.15 to the X over 2. So I'm just going to solve this one quickly, find out how long it takes for the population to reach 8,023. Just to practice 1 or 2 more times with the log relationship. So I divide by 1,500. So I get 8,023. So this is 5.348. So I get X over 2. This one goes on top. The 1.15 goes on the bottom. I'm just going to move this backwards as much as I really hate doing that. So we get log of that divided by log of 1.15 gives me 12. And then I multiply, that gives me 24 years. Okay. We'll just create the equation for this one. So here we have X is in days. So you're not going to go convert this to hours. Makes no sense. So it's just sometimes with the years, months thing that it would make sense. Other than that, usually it's pretty obvious. Number of insects. So it says the jar contains 200 insects, which I want this jar very far away from me. It says that it doubles, so the C is 2. D is, it says every 3 days, so the D would be 3. So Y equals AC to the X over D, and we just plug things in. 200, C is 2, D is 3. Everyone good with this? We're not too bad with the exponential now. Even with the added parameter, we're still okay. Speak now. All righty. Okay, so we have one last thing to talk about with exponential. This does not come up often, but it can, so we're going to take a look at it. Oh no. Give me 1 second. The formula disappeared. Class ends at 12:15. $12:15-ish. All right. Stupid file giving me an issue. I can stay for a bit to answer questions, yes. All right. We are good to go. So, no. This is not happening. Fine. Wants to be a pain. All right, you have this formula anyways. So this is called compound interest. So it is a special case of investing money. So it's a specific type of problem where you're investing money. You will know to use this because you will see the word compounded. You do not use this unless you see the word compounded. Okay? Do not use it unless you see this word. So the formula is y equals a 1 plus r over n to the nx. So it's just a little different. A is still your starting amount. N is the number of times that the interest is compounded per year. And the R is the interest rate for the whole year. So all this is a way to create an equation that looks different, but in the end it does the same thing. So let's just take a look at what these kind of problems look like. Susan invests $15,000 at 6% annual interest rate, compounded. So you're using that formula, quarterly. So we're going to create our equation first. So our x is always years for these problems, and y is the money. So we need A. A in this case is 15,000. Our R is the interest rate per year, which is 6. And the N is how many times it's compounded per year. It's compounded quarterly, so every quarter of a year, which means 4 times a year. But the R needs to be in a decimal. So we 6%, which is 0.06. So then we set up our rule. Whoop, NX. Which it will be 6, but just for the, oh my gosh, I'm about to do it again. So we get 15,000, 1 plus 0.06 divided by 6, divided by 4, because it's quarterly, to the 4x. Now, if you do this on the inside, you get 0.06 divided by 4, so you get 1.015 to the 4x. Now, all of a sudden, this is an equation exactly like we were dealing with before, and we can do everything that we did with it before. We just built it differently. So for instance, find the amount of money she has after 5 years, find out how long it will take her to double her money. So the first one, x equals 5. 1.015, 4 times 5. That gives you 1.015 to the 20. That gives you 1.3469, and then I multiply. That gives me $202.83. B says, how long will it take for her to double her money? So doubling the 15,000 is 30,000. Excuse me. So you plug in the 30,000. when I divide by 15,000 here, I get 2. I'm going to change this around using my log relationship. So 4x equals log of 2 divided by log of 1.015. When I type that into my calculator, I get 46.56, and I divide by 4, giving me x is 11.64 years. So that is why compound interest is a little differently to answer the question. So the question is, why is n 4? So the definition of n, just to go back quickly, the definition of n is the amount of times the interest is compounded per year. So if the interest is compounded quarterly, that means every quarter of a year it gets compounded. So every quarter means 4 times a year. So the first quarter gets compounded, the second quarter gets compounded, third quarter and fourth quarter. So it's 4 times in a year. So your n is 4. So let's do number 2, and then we can take a look at 3 and 4. That's why I said we'll take a look at number 2, and we'll do number 2, and then we'll look at 3 and 4. Okay, so the island of Madagascar was sold in the year 1618 for the equivalent of $21. If that amount had been invested at 3% per annum, that means per year, compounded monthly, how much would it be worth in 2020? So I've got my A is 21. I've got my R is 0.03. And my N, how many times per year? Well, if it gets compounded every month, there's 12 months. That's 12. So if Y equals, remembering that X is years, Y would be the dollars. I get A, 1 plus R over N with NX. So I get 21, 1 plus 0.03 divided by 12, and 12x. So my rule is 21.03 divided by 12 gives me 1.0025 to the 12x. It says, how much would it be worth in 2020? So if how many years have passed since 1618, or sorry, 2022. So 1618 and 2022 means 404 years have passed. So now I'm going to plug in. X is 404. So 12 times 404. So 12 times 404 gives me 4848. And if I type all of this into my calculator, we get, ooh, almost dropped my calculator here, 3, 7, 9, 5, 7, 6, 9.22 dollars. All right, let's just take a look at setting up the next 2 problems. So John invests $3,500 in an account that pays 4.5% interest per year, compounded bi-yearly. How long will it take for his money to double? So X is always years when you see the word compounded. So you are not using this unless you see compounded. So I start with 3,500. My interest rate is 0.045. And N, how many times per year? It says bi-yearly. That means 2 times per year. Y equals A, 1 plus R over N to the NX. So we get 3,500, 1 plus 0.045 divided by 2. And 2 goes up here as well. And I can reduce what's inside my bracket, 0.045 divided by 2. So that gives me 1.0225 to the 2x. So, and from there, whatever they ask you to do is the same as what you've done before. The only thing that is different is how you create this equation. So then I'll leave you to try to answer this question. Oh, dumb, this question's important. Bill Gates wants to invest $16 million for a period of 11 years. He has 2 options to choose from. Give the amount he will have after 11 years in both cases. So you have 2 different options, which means you're creating 2 different rules. This says annual interest rate of 6.75 paid once per year. All right, so I don't see the word compounded. So I do what I normally do. A is the 12 million, 16 million. My C is 1 plus 6.75 over 100. So the 6.75 over 100 gives me 1.0675. And once per year means the D is just 1. So my equation is Y equals 16 million. 1.0675 to the X. But this one says compounded monthly. So I know that I need to use the other formula because I see this word. Still starting with 12 million, 16 million. Why do I keep doing that? I did in the other class too. C, we don't have. We have R, which is 0.065. And my N, monthly, means 12. So it's 12 times a year. So my equation is A, 1 plus R over N to the NX. Then we just fill in what we know. Maybe I meant to write 12 and I wrote 16 because that's ridiculous that I keep doing that. And then we just reduce the inside. So you get the 0.065 divided by 12. So here you get 1.005416 to the 12x. Try to keep as many decimals as possible. Now, what this question says is compare the two when the years is 11. So in this equation, you would just plug in x is 11, and in this equation, you would just plug in x is 11, and then you would compare the two amounts. Any questions? Okay. Here's what's going to happen. Your assignment 10, I will only take a look at it on Wednesday because there's one bit of probability on it that we'll cover on Monday. So that'll give you an opportunity to work on it Monday, Tuesday, and then I'll take a look at it on Wednesday. For those of you who have not submitted some assignments, please submit some assignments. Okay. You really need to submit as much as possible to get as much feedback as possible. I'll be posting a list of topics this afternoon for your SIP prob, and don't forget you have the mock memory aid. I'm also going to post a couple of like practice finals, mock final kind of things that you could take a look at, but obviously the priority right now is for the SIP prob. What was I going to say? Oh yes, so we're a little bit behind the other class. So what I do want you to do is there are notes here that we didn't get to for probability. So we were starting probability. We're going to be doing probability on Monday and Tuesday. So just take a quick look through them, please. At least read them. That way, as I'm doing it, I'll pop, they can, your questions can pop up and you can take notes or whatever. So make sure you read that so we can kind of go through this really quickly to get to the new part of probability, because most of this should be review until we get to just before the end, and then on Monday, Tuesday, a lot more review stuff. Are there any questions, any concerns, anything? I'm not going through assignment 9 right now because we just finished the material for assignment 9, and the idea is that now it's for you to practice. So I want you to try it on your own. I don't just want to go through it for you. So you can try assignment 9, and then on Monday I can go through it when you've had the opportunity to actually try it with all the tools that you need to do it. Okay, so the assignments are for you to practice, not for me to just show you, because I'm already just showing you the problems in class, okay? The solutions for assignment 6 have been posted. Assignment 9 is actually a little bit more straightforward than it seemed at first glance if you really go over the stuff that we did today. I will be providing feedback for assignment 9 on Sunday. So I will definitely be giving you feedback on assignment 9, but I'll be going over it on Sunday. Everyone's at the same time, okay? Anything else? All right, if there's nothing else, no other questions or anything, things to remember: read over these probability notes. Look for the list of topics for the SIP prob. Go over the assignments and resubmit as many as possible. On Sunday night, I'll take a look at all the resubmissions for the weekend. If you have any questions, please feel free to email me at any point during the weekend. I'll get back to you as soon as I possibly can. And if there's nothing, I'll see you all Monday morning bright and early. Have a great afternoon and a great weekend. Can you still hear me? There are two reasons. Okay, so the reason I don't, for the last couple of topics, I have